Hi there, guys. My name's Paul Warren. I know I'm keeping you from lunch, so I'll try and keep it on the half an hour, although I've got a fair bit to show you. Welcome to my talk called Persistence Arrives on Cloud Foundry. It's a pleasure to be at the Spring One conference talking to you, honestly. I spent 22 years as a software engineer. I've been a software engineer my entire career. I'm very proud of that fact. Never, ever been in management. To finally come and talk at Spring One is a bit of an honor, to be honest. So I'm from the EMC Cloud Platform team. What is the EMC Cloud Platform team? Well, we're a small division within EMC, and we kind of have two remits. First remit is to commit on open source, specifically Cloud Foundry and its ecosystem. And why do we do that? Because under the rules of the Cloud Foundry Foundation, by committing on open source, you earn votes, right? And if you earn enough votes, then you can steer CF in ways that are mutually beneficial for Pivotal and for EMC, and then, of course, for our partners and our customers. And that's all done on the West Coast. So although I'm an EMC employee, permanently based in the Pivotal office in San Francisco, and currently I'm a committer on the Percy project, which is the persistence project I'm talking to you about today. Previously, I was a committer on UAA. On the East Coast, they have a slightly different remit. They produce some product, which I'll talk about today. But they actually, having learned the way from Pivotal, right, learned the way, and we've all been through the Pivotal dojo. My colleagues on the East Coast in Cambridge, Massachusetts, now go teach the way. So they do Pivotal lab-style engagements with other divisions within EMC, right? And we bring the DevOps culture and the agile methodologies, and they bring the domain expertise for their particular product, and together through pair programming, pair PMing, all right, we try and figure out how we can fit their product into the Cloud Foundry ecosystem or the cloud in general. And through this process, we're trying to transform EMC. Right? EMC knows as an enterprise it's got to undergo this transition to be successful. And so persistence on Cloud Foundry then, probably one of the most popular feature requests we get. Right? And if we start to look at the Wikipedia entry for unstructured data, perhaps we get an idea why that might be. So back in 1998, Merrill Lynch cited that somewhere between 80 to 90% of all potentially usable business information may originate in unstructured form, i.e. that's files living in folders on some EMC Isilon cluster somewhere, hopefully, right? And my own company, EMC, projects that data will grow to 40 zettabytes by 2020. And that's a 50-fold growth in just 10 years. And that's a pretty incredible explosion of the amount of unstructured data that's out there. And when we say unstructured data, we're talking about files, right? We're not talking about data that's in databases. And when we talk to customers, we start to see that. So we've got a lot of customers there that have like LAMP stack style applications, your kind of WordPress, kind of CMS style things, right? And whilst they store some of their information in a MySQL database, obviously, a lot of the themes, a lot of the WordPress plugins, right? Any content you upload to WordPress is actually stored on the file system. Right? So as it stands today, or a little while ago, it wasn't possible to run that on Cloud Foundry. Talking to other customers, the other day I was talking to a customer. They've got a knowledge base of terabytes of information, almost, well, gigabytes of information that of marketing literature, sales, product, technical information, and so on. And when they begin an engagement with a new customer or prospect, they create this kind of virtual folder that they offer to the customer through the web interface, and they like to drag documents out of that kind of knowledge base that are relevant for that particular customer, stick them in the virtual folder, give that virtual folder to the customer to peruse at their leisure. Another use case is big engineering companies, which will remain nameless, but talking to a couple of big engineering companies, they've got hundreds of AutoCAD users, and they're sitting there creating their AutoCAD designs, right? And AutoCAD saves. They save all that information to an EMC Isilon cluster, right? And then in the background, they've got these applications that process those AutoCAD designs, right? And spit the processed AutoCAD design back out on an EMC Isilon cluster, right? And they want to uplift that whole thing onto Cloud Foundry, but up until recently, they weren't able to do that, right? Another customer, satellite images, they've got terabytes of satellite images that stream onto EMC Isilon, Right? And then again, they have this application processing that runs in the background, processes those satellite images, puts it back on EMC Isilon. They want to uplift that application onto Cloud Foundry, and they can't. Why can't they? Because when it comes to a Cloud Foundry perspective, it was all about 12 factors, right? And if your app wants to persist any state, then you have to persist it in a backing service. And up until recently, those backing services were all network attached only. Right? If your application had a connection to the file system, you were done, right? You couldn't push it to Cloud Foundry. And so, we were going to the customers and we were saying, well, you want to use Cloud Foundry, and at the same time, they were going, that's great, but I've got all these applications over here, and you're telling me I can't run those. But we wanted to look at the ecosystem as a whole. And so if we looked at the layer above, right, the Cloud Foundry is a tool for developers. Majority of the developers out there are Spring developers, right? 38% are in Java, Spring. So if we look at that ecosystem, how do they deal with unstructured data up there? How do we deal with files up there? And Spring, over the last couple of years, has undergone a fantastic transition. I love Spring, right? I've been a Java developer since V1. It's amazing. And it really is the new J2EE, right? And Spring Data is this brilliant framework that allows developers to manage their structured data with little to no code. Really, really good. However, if you look at its handling of unstructured data, it's not so hot in that area, all right? The JPA module for Spring Data allows you to handle blobs, but that's not transferable to any of the other databases out there, right? It's not transferable if you wanted to do that on Mongo. It's not transferable if you wanted to do it on Cassandra, and so on. And so we saw some opportunities here, right? What if we add volume support to Cloud Foundry? And in effect, the best way of thinking about this is, and the way I think about it is, what if we extend Cloud Foundry in such a way that if you have apps that write to the file system, they automatically become 12-factor apps? Right? What if we did that at the Cloud Foundry level? That would enable a lot of our customers to then move their apps up onto Cloud Foundry. And then what if we added uniform handling for blobs into Spring Data? Right? What if we did that, which would then allow our customers to modernize those apps, right? And begin that journey from monolith to microservice. Right? Begin that journey from moving their data perhaps from EMC Isilon to EMC ECS, which is our S3 compatible object store. And so beginning of January, we set about that journey in collaboration with Pivotal and, in fact, IBM. And that's what I'd like to show you today. I'm also going to show you a new open source project that's coming out of my division called Spring Content. And that addresses that Spring Data blob handling that we're talking about. And so what I want to do today is show you 2 Spring Boot, Spring Data, Spring Content apps that are going to share files on a remote file system by binding that remote file system to the application containers that those apps are going to run in Cloud Foundry. Right? That's basically what we're up to today. So let's have a quick look at Spring Content and an overview. I just want to point out, right, this isn't an official Spring project. All right? Okay. I'm beginning socializing it with the Spring guys. I wish it to be an official Spring project, but it isn't right now. But what it offers you is extensions for Spring Data that add primitives for handling blobs. Right? So it's the same interface-first approach that you get for your structured data, we're now offering for your unstructured data. Supports Spring Boot. So basically, it kind of wires itself all together in this really kind of opinionated but cool way, based on what you've got in your class path. It also supports Spring Data REST. So you know if you're writing a Spring Data app and you put Spring Data REST on your class path, you automatically get endpoints that allow you to do CRUD on your entity beans over REST. Right? We support that too. So if your entity bean also supports content, you get REST endpoints that enable you to get and set your content over REST as well. Right? And we've got some more kind of content management type features in there. A very common use case is if you're trying to write these type of apps that do content management-y stuff. I come from Documentum, by the way, originally. you tend to see things like, well, I've got some Word docs over here, got some Microsoft PowerPoint presentations, but I want them in PDF format, right? So you need kind of to be able to transform the content from one form to another. So built into this thing as well, there's things like an extensible rendition service, so you can do stuff like that. Currently, we support JPA, we support Mongo's GridFS, so you can store your content there. S3, obviously, we support, and the subject of today's talk, obviously, is the file system as well. And this is really a key characteristic. So it's really interesting when you start adding this into the Spring Data mix, because it allows you to separate the content from the metadata that manages that content and gives it meaning. And this is a very powerful construct, and it's what every single content management system out there today is based on. This is the central tenet that they're based on. Because you always want to store the content separately from your metadata. You don't want to put the content in the database because you need to do things like dedupe it and stuff like that. Okay, so let's do a quick app walkthrough. Show you this real quick. So we've got two apps we're going to push, right? And we've got a shared data model. So let's have a look at what that looks like. All right, so you can see here I've got my standard Spring entity bean, all right? I've called it file, all right? I've annotated it with @entity JPA annotation, right? And I've got some attributes that I want to store, some metadata I want to store about that file, all standard Spring Data stuff, right? But you can also see that I've annotated it with the @content annotation, right? This is Spring content at work here, and because I've done that, what that allows me to do is associate some content with this metadata and store it. And because it's Spring content, I've added some additional simple fields on here. And Spring content will actually, based on the content you get and set, it will actually automatically manage these attributes that you've annotated. Okay, and so you get a little bit of metadata about the content-specific metadata as well, like content length and MIME type. And then down below, you can see I've got all my getters and setters. So how do I expose that? Well, standard Spring Data, right? You would expect to see an interface that extends a CRUD repository. That's what we've got here. And you can see that I have annotated it with the repository REST resource, which means I want to, at some point, export this as a REST API. And then likewise, Spring Content offers the same interface-first approach for the content handling. So here I've got a file, content repository. So we're calling these things content repositories. And it extends content store. And you can see if I go into this thing, this offers ability to handle content. I can get and set content now, as well as perform CRUD on the actual entity bean itself. And so that's our data model that we're going to share across our two apps. Let's have a look at our two apps real quick. So the first one we're going to do is we're going to actually push a fully functional WebDAV server out there. This is my favorite retro REST interface, right? WebDAV was REST before REST even existed, almost. And so I'm using a third-party library called Milton, which is providing all the WebDAV plumbing. So let's have a look at the dependencies of this thing. You can see it really is a Spring Boot app. So it's got a parent POM, which is using Spring Boot starter parent. I'm a little bit out of date. I apologize. I haven't had time to update this. If we have a look at the dependencies, you can see it's got Spring Boot starter web on there, Spring Boot starter data JPA, MySQL connector, and it's got Spring Boot content for the file system. So we're planning to store our content on the file system. And we've got the shared models library on there too. So how do we use that? Just real quick. All right. So I've got a Spring controller here, but this is provided by Milton. It's a WebDAV specific kind of Spring controller. And the way it works is you annotate methods on this class, and when a request comes in from a WebDAV client, right, it will figure out which method's called based on the annotations. And so you can see that I've injected my entity bean interfaces in here. And obviously, when you run this at runtime, based on what's on your class path, you're going to get a wired-in implementation for the thing that you've got on your class path. So because I've got Spring Data JPA on my class path, in that file repository, I'm going to get a wired-in implementation that allows me to create, read, update, and delete entries in a JPA database. And because I've got Spring Content File System on the class path, I'm going to get wired into the file content repository bean. I'm going to get a working implementation that allows me to get and set content streams on the file system. And I get that without writing any code at all, literally these two injection points. So how do we use that then? So let's have a look at the create file method here. It's annotated with that put child. And so this is the method that's going to get called when a web dev client tries to create a new file in the file system. And it gives me the name, and it gives me the stream. And all we do is create an instance of the entity bean we looked at earlier. And we call on the file repository, we call save to save that. That will save it off in the JPA database. And then we take the body of the file, and we call set content on the content repository that we wired in. And that will save the contents onto the file system. Right? And you can see to get the content, we do the same thing. We call get content on the contents repository. And we copy it to the output stream that's going to go back to the client and present the content. And so on and so forth. So that's app number 1. That's our read-write interface. App number 2 is demonstrating Spring Content REST. So you can see it's got all the same dependencies on it. It's got Spring Web, Spring Data JPA, Spring Data REST. So we want to automatically export REST endpoints for this. And it's got Spring Content for the file system, and it's got Spring Content for REST too. So you get the REST endpoints for your app. And just to demonstrate that point, right, zero coding in this new Spring world. So you can actually have a look at the server side of this app. It's this. It's one class, right? It's the Spring Boot application class. I've got no code in here, right? Spring's giving me all of the implementation for free. Really cool. All I've got is a little very simple Angular client-side app, right, which presents a list of the files that we saved off into this shared volume. And we should be able to prove that we're sharing them. Okay, so that's what I've got there. So let's go ahead and get those pushing up to the cloud. So I'm going to go ahead and push my web dev app. Oops. And I'm going to push my web app. Those are 2 apps we looked at. All right. So they're pushing, all right? So let's go back to our presentation. Oops, wrong one. And play. All right, so we've had a look at Spring stuff. That's pushing in the background. We'll come back to that later. Let's change tracks. Let's talk about persistence on Cloud Foundry. Like I said, this kicked off early January in collaboration with Pivotal and IBM. And I think the best thing to do, right, is picture paints 1,000 words. So let's have a look at what we actually added architecturally. And so here's a simplified overview of the Cloud Foundry architecture. It's simplified, right? Don't shoot me. It is definitely simplified. And so you've got the cloud controller, which is where, what the CF CLI talks to. And then you've got the BBS, also known as babies. That's like the entry point for Diego. So that's what the cloud controller talks to when it wants to actually make the runtime do things. And then we've got a depiction of a cell. So a cell is the VM, or there's a bunch of these things, right? And these are the VMs that actually run your app containers. And then inside that cell, we've got Garden, right, which is our version of the Docker runtime, effectively, right? It's our container runtime. And so what additional things have we added to this picture? Well, we're talking about, is that 10 minutes to go? Okay, we're talking about volume services. So outside of Cloud Foundry, we've got some sort of volume service, all right? EMC Isilon, for example. In our world, we have a reference implementation, which is Ceph, because it was fairly neutral for all 3 companies. And it was also a bit future-looking because it provided block support. And in the future, maybe we'll support something like EMC Scale.io, and I'll come back to that a little bit in a minute. We decided to surface this through the standard service broker semantics, and I alluded to why earlier. We wanted to make this extend the platform so that apps that had dependency on the file system became 12-factor apps. That was one reason. Another reason was we wanted it to look and feel just like any other service to the developers. And a third reason was when we looked at all these kind of things like when we looked at the category of distributed file system like NFS, for example, and not all NFS are the same. There's subtle differences between each of them. And so we wanted the developer to be cognizant of the actual NFS that he was connecting to so that he knew exactly what he was getting, rather than kind of hide it under the covers and just say, well, we support NFS, and try and handle that ourselves. On the cell, we put a volume manager, and this manages one or more volume drivers. You can have multiple of these on the cells. And these things expose the Docker Volume API. When we started this work and we looked at what was out there, there was no standard for volume management. But Docker was obviously a fair way down the road with supporting volumes already. We had a look at their API, and it wasn't horrible. It was fairly decent. And we also looked at the ecosystem that was popping up around that. And there was a fair few volume plugins being written. And we liked the idea that we could reuse these in our world. So we chose to support the Docker Volume API. And in fact, having used it for a while, there's a couple of deficiencies in it. So we're now actually talking to the Docker guys, and we've got a pull request in to make some updates. And they're so far looking like they want to work with us, and that's great. OK, so like I said, exposed to the standard service broker semantics. So how do we interact with this thing? Well, let's go back to our app and find out. So we're going to create a service here. All right. So my two apps are out there. Oops, I don't know what I copied there. We've got our two apps pushed, but not started. So there's a record of those things out there. And I'm creating a service now. So it says create service. And I'm using the Ceph broker app there. So I'm talking to the CephFS broker. Right? So that's the service broker that manages CephFS volumes. And I'm saying, instantiate me an instance of the free, don't ask me where we got these names from, instantiate me a free plan, please, and call it shared volume. So that's what we've done. So what actually happened underneath the covers there? Let's have a quick look. So I called CF create service. Cloud controller received that request, and it forwarded it onto the Ceph broker. Right? We just saw that. And the Ceph broker went off and did whatever it needed to do to create a volume on the Ceph file system. In our world, it does something really, really simple, like creates a folder which is named after the service instance ID. Right? So it does something really, really simple, and then that's ultimately what we bind into the app container. But we envisaged that other service brokers could do things really quite sophisticated, like they could go spin up a whole new dedicated instance of the software-defined EMC Isilon, which is called EMC Isilon Edge. Right? We could do something cool like that. OK, so we've now got a service out there. We need to make our apps use it. So we need to bind our apps to that service. So let's have a look at that. Back to our world. You can see here I've got CF bind service. So I'm going to bind that service. And then I'm going to bind the web service. So we've done this. So I've said CF bind service, webdav to the shared volume. And I'm actually giving it a -c instruction and saying, I want you to mount this remote folder at the location /home/vcap/data. Right? And in both my web applications, I told them to write their files to that location in the container. Right. So what actually happened there? Let's have a quick look. So we just called CF bind service. That was received by the cloud controller. The cloud controller talked to the Ceph broker and said, OK, this app wants to bind. And the best way to think about this is service brokers are now capable, and this is one way the only place we really had to extend Cloud Foundry, other than the runtime. Service brokers can now issue one or more volume mounts to the Cloud Foundry runtime. And a couple of things happen when a service broker does this. First thing that happens is Cloud Controller will talk to BBS and say, I've got some volume mounts for you. BBS will forward those onto a cell that's going to run the app and say, I've got some volume mounts. Could you prepare these for me? And Volman will talk to the relevant driver. In this case, he'll talk to the Ceph driver. And the Ceph driver is the thing that's responsible for then mounting that remote folder or remote volume at the cell level, at the VM level. So that's step one. Step two, BBS will then talk to Garden and say, yeah, that volume mount we just made at the VM level over there, take that volume mount and bind mount it into the container that you're going to run this guy's app in. And so it becomes available to the app. And that's what happened under the covers. And so let's have a look at that in action. This is where it gets really scary. So first thing I'm going to do, obviously, we've got a WebDAV client built into Finder. So I'm going to connect. Oh, go. Oh, sorry, I tell a lie. We need to start these things. I should have done that. OK, so these things are starting. So maybe I'll go on to futures as we're running short of time. Talk about that a little bit. So they're starting in the background. I'll come back and show you those. So where are we going with all this? Well, file system stuff's ready for you to use. Okay, if you want to go and use it, or you want to go and try it out, we've got a local volume implementation which runs on Bosch Lite. And on that, I'll show you the link in a minute. You can just go run that yourselves. We've also got the CephFS implementation. If you want to try that, that's like a real remote file system as opposed to a mocked up one. So you can also try that. But where are we going? Well, we're considering block devices. And block devices are a lot different to shared file systems. Shared file systems, the file system handles all the concurrency for you. And Diego has what we call a highly available scheduler. So it will actually over-provision in order to maintain the service level agreement with the developer. So if a developer's asked for 10 instances of his app, he's got 10 containers with his app running. If the operator comes along and rolls Cloud Foundry to upgrade it, for example, what will happen is Cloud Foundry will spin up 10 new instances, so you've got 20, right, before it takes the 10 old ones down in order to maintain that service level agreement that he has with the developer. And you can attach shared volumes to those apps because you can have as many of those attached as you want, and the file system will handle the concurrency for you. If you start attaching block, we all know, right, that can only be attached to one thing at any one time. So at the point Cloud Foundry tried to attach that to us, any second instance, in any scenario, it's going to fail. And so we need to add what we're calling like a highly consistent scheduler to Cloud Foundry. And that's something we're talking about at the moment. If we get there, then we really does open the door to doing things like CF push MySQL, right, and running your services on Cloud Foundry itself. And that's something that actually we're very interested to hear from you guys, the community, about whether that's something you want. Okay, let's go back to our apps and see where we're at. Let's try and connect. Okay, we're in. So very quickly then, my username and password. Are we connecting? Are we not connecting? Oh, I think we've got some conference Wi-Fi going on. That's not good. Okay, well, let's give that a couple of seconds. Okay, so that's on the persistent side. So very interested to hear from you on block. On the Spring content side, this is a very early project. It's all out there. You can check it out. I'm thinking about separating the blob side of it out from the content management side functions to make it more kind of accessible to the Spring guys. The JPA module does something really dumb right now, so I need to make that a little bit more sane. I want to add things like eventing around getting and setting content so that developers can kind of plug into that and do their own thing. And then I would like to, add more content management-like features in addition to the rendition service, things like retention services, so you really can place holds on your content and stuff like that. Okay, let's see. Are we there? Oh, we're there. All right. Okay, so hello, Spring World. So what I'm going to do is, oops. I'm going to save this onto the WebDAV server. And if we go into that, you can see there I've got my hello files actually saved onto my web dev server. And then if I go back to my app and we do CF apps, I can grab the root for the read-only interface, the web interface. That was the one that was demonstrating Spring Data REST. And if we jump over to Google real quick, stick that in there, you can see I've got a list of files. So I've got a few extra files in there because Finder likes to write temporary files everywhere. And if I click on that thing, you can see it brings up my content. So I really have shared those files across those apps. And if anyone's interested afterwards, I can show you, like, we SSH into the container. I can show you the volume mounts and so on. OK. I think I'm a little bit over time. I know it's lunchtime, but I'm happy to take any questions you may have. If you're interested in giving persistence a go, there's the local volume release. My colleagues on the East Coast have written a broker and a driver for EMC Isilon. So if you wish to give that a go, there's the link for it there, the CF Persist Service Broker. And if you want to give Spring Content a go, then it's out there in EMC Dojo organization, Spring Content. Thanks very much.